Hey guys, welcome back. I'm really glad to see you here because I've been looking forward to doing this question. All right, let's read and see what our challenge is. It says determine an expression for the nth term if the fifth term is 9 and if the ninth term is 729. Also, the sequence contains alternating positive and negative terms. The moment you read something like that, you already know that it's geometric. Okay, because you can't have a positive and then a negative and a positive and a negative if we're only adding and subtracting, or either adding constantly or subtracting constantly, right? Impossible. So we know this is a geometric sequence. Wicked. Okay, let's talk about the information they've given us. They've told us that the fifth term has a value of 9. Okay, let's talk about how we would represent the value of 9 algebraically. Okay, we know that we always take the first term, which is a, we multiply it by the ratio, which is r, and then we put it to the power of n. Now in this case, the n is going to be the position, right? We know it's going to be 5, so it's going to be 5 minus 1. Let's clean it up once more. So it's going to have a times r to the power of 4. That is what T5 is, and that is also equal to 9. Wicked. Okay, let's go on to the ninth term. So T9 is now equal to 729. Okay, putting this into an algebraic representation, we know it is a times r, and the position is 9, so it'll be 9 minus 1. Cleaning that up for a final answer is ar to the power of 8. Okay, hard part done. Well, pretty much the hard part done. Now remember, when we're doing geometric sequences, we always want to take the larger term and divide it by the smaller term so we get the constant ratio. Guess what? We're going to do exactly the same thing. So let's grab it. T9 divided by T5. Now this mumbo jumbo that I've just written here, okay, that's just to help us set up what our equation is going to be. Okay, so the value of T9 is 729. Okay, the value of T5 is 9. I want to say that is equal to, remember, our algebraic expression. So the algebraic expression for T9 is a times r to the power of 8, and we're going to divide that by a times r to the power of 4. Okay, is this looking good? It's feeling good to me. Okay, let's go ahead and simplify what's happening here. I'll grab another color. A divided by a, they're going to cancel each other out. We have r to the power of 4 at the bottom of our fraction and r to the power of 8 at the top of our fraction. We know we're going to subtract them, so it's going to be 8 minus 4, and that's going to give us r to the power of 4. Okay, now we're going to take 729 and divide it by 9, and we get 81. 81 is equal to r to the power of 4. All we've done is cleaned up, okay? Now, what you can do is grab your calculator, plug in what is the fourth root of 81, and you get r is equal to 3. So 3 to the power of 4 would give you 81. That's what we've literally calculated. Well done, guys. Okay, now what we need to do is find out what our a value is. Again, I'm going to go with the easier little dude, and that is going to be T5. Okay, so T5 we know is equal to ar to the power of 4. Okay, we don't know what a is, so we'll leave it as is. But we know that the ratio is going to be 3, and that needs to be to the power of 4. But what is the value of T5? It is 9. So we're going to check that on the left-hand side. Okay, let's find out what is 3 to the power of 4. We have worked out that that would be 81. So we have a times 81. Okay, and on the left hand side we have 9. In order to separate the a and the 81, we're going to divide by 81, and we're going to do it on both sides so we keep a balance, and that gives us a is equal to 9 goes into 81 9 times. Oh, it gives us 1/9. Okay, we have 1/9. Oh, yes, 1/9. Something I just want to point out here, notice that it says here at the end we have alternating positive negative terms. What I've actually done here is I should have had for 9 is equal to a open bracket negative 3 close bracket to the power of 4. Okay, when you check what the value of that is and you put it into your calculator, make sure you open a bracket. You put in your small little negative that you will find on the third row on your calculator, and then you say 3 close bracket to the power of 4, and it will give you 81. Okay, so our process is still exactly the same. We just forgot that negative. Okay, it happens to all of us. Don't let yourself get caught out. Okay, so we know that the r is meant to be negative. And how do we know that? Because they told us it is an alternating positive and negative term. Okay, so we now have ratio. We have the first term. Let's go ahead and test it against 9. Let's check if this negative is right. Okay, so we've got T9 is equal to a times r to the power of 8. Okay, we have surmised that a is 1/9, and our r is -3, and that is going to be to the power of 8. Okay, nothing's going to happen to our 1/9 multiplying. Okay, and we're going to say, what is -3 to the power of 8? I'm going to plug it into my calculator. Open bracket, the small negative, 3 close bracket to the power of 8. And that gives me, oh my word, that gives me a huge number. 6,561. Cool, let's divide that. Oh no, we're not dividing. Let's multiply that by 1/9. And that gives me 729. And that is the exact value that they gave us earlier. Awesome! That means that we have just proven that our values of a and our values of r are correct. On to our last step, which is just creating the actual general nth term. So cool. Okay, so let's talk about what is our standard form for a geometric sequence, and that is a(n). What am I saying? A(n). Tn is equal to a times r to the power of n minus 1. We're just going to plug in the information that we've just calculated, alright? So the value of a is 1/9. Okay, the value of r is -3. And then we're going to say n minus 1. And that's it. That is your general nth term. Guys, we have completed this challenge and we totally got it right. Thanks for joining me. I hope to see you on the next one. Cheers, bye.